3, 2, 1, done.
Thank you very much. The basic concept behind translational software is that there's an enormous amount of new technology coming into healthcare to handle genetics. But it's never going to come to fruition unless there is the technology to make it accessible and usable to doctors. And that's what we do. The basic concept came, or the epiphany came, from reading the story of Annie Parker, who had scheduled surgery because of a family history of cancer. She found at the last moment that she didn't have the bad mutations. And that gave me the idea that this is a really important need for information. And just as the computing industry was driven by software, the cost of genetic sequencing is dropping 3 times as fast as Moore's Law. And that creates an enormous opportunity for us. What that means is that the amount of knowledge about medicine is growing, and it's accelerating at an accelerating rate. But that never will really reach its potential because right now doctors are at their limit, their cognitive limit in terms of what they can, the facts that they can use to apply to decisions. So the challenge is to say, how do we help? What information system is going to help us to help the doctor to make a decision? Now, we decided among all the places we could concentrate, we decided on pharmacogenetics, which is the relationship between drugs and genes, for a couple of reasons. One is that there are a very small number of genes that affect a very large number of drugs. So a small company can actually make an impact there. The other is that the area is pretty well studied. The FDA for years has been looking at these relationships. So what we built is a cloud-based system that sits between the lab and the doctor. Our customer is the lab, that takes the A's, G's, C's, and T's and turns them into something worthwhile for the doctor. What we noticed is that right now, the normal reports are focused by molecular biologists for molecular biologists. So they expect the doctor not only to understand the biology or the genetics, but then expect them to figure out how that applies to their customer, to their patient. What we did was said, let's start with the evidence and work back from there to the genetics. So we can tell the doctor, for this patient with this genotype and this medication list, this is the best available evidence about how you should dose that drug or any other drug that's covered by the genes in the test. What we learned was, one, when you're working with biological data, it's really messy. Secondly, developers and PhDs can work and play nicely together. And third, if it's not reimbursed, doesn't matter how cool it is. The other thing we learned is that doctors are incredibly busy. So they have to see 30 to 40 people per day, if you can imagine what that's like. So what we have to do is really refine and really test and really focus on these reports and make sure that they are absolutely as concise as they possibly can be, that the wording is accurate. So what we did right. First of all, we started when people told us we were crazy, and we might have been a bit. That was 2009. Our first customer was last year. We also partnered with the people that are building this equipment because they know that with our software, their hardware is a lot more compelling, and that has made a huge difference. Virtually all of our customers come from referrals. Where are we now? 12 people, solid revenue growth, and profitable for this year. But we're not out of the woods because of Medicare. Medicare is looking carefully at what we do. Where are we going? Today, you test a single gene for a single drug. What we're enabling you to do is test 15 genes, which is not much more expensive, and know from that 150 drugs what's important. Where we want to go is to put this data in your medical record, so every time you make a decision in the future about a medication, you can come to our database and know what the implications are. So let me tell you one story to finish. 2 weeks ago, I found out about a transplant team in New Jersey. They were losing a patient, and the patient had a rare tissue type, so there weren't a lot of options. they, in desperation, went for a genetic test. They used our report. They identified the source of the toxicity for that patient, modified the medication regimen, and that patient not only survived, but thrived. So that's what keeps us going, and thank you very much for the opportunity to share it with you. Questions? Yes, sir. The biggest competitor right now is labs that want to do it for themselves. They say, we want to have a differentiated solution to this. And I think it's just like when I was in IT back in the 1990s, you said, well, I have to have my general ledger system or my CRM system. There'll be a tipping point in the future when they say, well, we can't be competitive if we do it themselves. We're not quite there yet, but pretty soon. Consumer is tricky, and 23andMe, you probably know, has been shut down by the FDA. We very, very intentionally sell to the doctor, or our customer is the lab, and they sell to the doctor. And the reason for that is there are an awful lot of considerations that we can't incorporate into the reports. There are a lot of things about renal insufficiency. There are lots of things that just can't be incorporated. And I'd much rather have a doctor work with our report to bring it to the customer, to the patient. Yes, sir. We do have some customers that will bring the reports to consumers. And they will offer the support that's necessary for a patient, but for every patient that is well-informed and pragmatic about using the information, there are some that are less pragmatic.
One more question?
Yes, sir. We actually get off the machine, and it's usually PCR, not sequencing, if you're familiar with the technology. We don't need 1 billion genes. It's about 15. They're about 180 or 90. The cool thing is that right now, there isn't really a lot of actionable data. So we get genotypes. So it's just what variant you inherited from your parents at that locus. No, not actually the protein. We know based on the genotype, we'll convert that to haplotypes, and based on the haplotypes, we know the predicted clinical phenotype, and based on the clinical phenotype for a particular gene, we know how you should modify the dosing of the drug.
Not to cut the question short, but I would love to hear this over tacos and beer. I got to tell you, that would be awesome. But ladies and gentlemen, translational software.